Training your AI models is not enough. You also have to figure out if it is actually good. Does it behave the way you expect? Does it hold up in the real world? Or is it just looking smart inside your notebook? For traditional machine learning, this used to be simple. For LLMs and voice agents, it is one of the hardest problems in AI right now. Today, we will walk through how evaluation evolved from classical ML to LLMs to AI agents and finally to real-time voice AI agents and how we think about it at Nurix. Let us start from the familiar world of traditional ML. If you have a classification model, the first metric you probably think of is accuracy. Accuracy is simple. Number of correct predictions divided by the total prediction. It is easy to understand, easy to compare, and looks great on your slide. But accuracy can lie to you. That is why we use precision and recall. Precision shows you how many false alarms you raise, and recall shows you how many real cases you missed. They tell different sides of the same story. Hence, we often combine them into one number, the F1 score, which is the harmonic mean of precision and recall. In traditional ML, it is quite structured. But as soon as you move from classical ML to large language models, things change. LLMs are non-deterministic. You are no longer just asking, did it predict the right label? You are asking things like, is this answer actually useful? Is it factually grounded? Does it follow my instructions? Over the last few years, the number of LLM benchmarks has exploded. Where we used to have a handful of benchmarks, now there are hundreds. MMLU, Truthful QA, Humanities Last Exam, and all the safety and bias test suite. People also started using LLMs as judges. One model generates an answer, another model grades it using a rubric. In many settings, this can correlate quite well with human judgment, but you need several iterations to get it right. But even with all these numbers, evaluating LLMs is still messy. Multi-turn conversations usually drop performance compared to single-turn prompts, and two models with very similar scores can behave very differently in real world. So even at the LLM level, evaluation is not just a single metric. It is a whole set of decisions about what good means for your product. Now, let's take an agent. An agent is not just answering questions. It is thinking, planning, choosing tools, calling APIs, coordinating with other agents, and finally producing a response. Which part do you evaluate? You can have an agent that gives a correct final answer but uses a terribly slow and expensive plan. Or the opposite, a great plan that fails miserably because it didn't recover from this one failure in the last step. This is why people talk about different types of evals: final response evaluators, trajectory evaluators, single step evaluators, and much more. Tools like Langsmith, Langfuse, and products and companies like Galileo are trying to give visibility into this whole process. They track cost, latency, success rates, and allow you to inspect individual tool calls and trajectories. But here is the real challenge. The space of possible trajectories is huge. So again, you're not comparing to a single correct path. You're comparing to a range of acceptable behaviors while trying to avoid bad ones. And then we arrive at the fun part. Voice. Voice agents are like assistants on hard mode. You are no longer just dealing with text in and text out. You have layers of entirely new modality. First, the input layer. This is everything that happens before the model even starts responding. For example, ASR accuracy in ideal lab conditions can look great. The moment you add real-world noise, it can drop 20 to 40%. If you add strong accents or code switching, it gets even trickier. In a country like India, with hundreds of languages and thousands of dialects, this is a very real problem. And on the reasoning side of things, once you have text, the model still needs to understand intent, follow multi-step instructions, look up knowledge and call external tools, avoid hallucinations, and decide when to say, I do not know, and when to escalate it to a human. All of this while maintaining a real-time latency. Everything we talked about for LLMs and agents show up here. Even if the response is perfect, you still have to speak it back to the user. How fast do you respond? Does the tone match the situation? Does the prosody feel natural? Does the persona stay consistent across calls? In human conversations, natural turn-taking latency is roughly 300 to 700 milliseconds. If your agent takes more than 1200 milliseconds to respond, the interaction starts to feel laggy and robotic. So, in voice, you cannot just look at what the model said. You have to look at how quickly it said it, how naturally it said it, and how often it got there through a robust chain of reasoning. This is why people at companies like OpenAI and Anthropic keep repeating the same message. AI evals are becoming one of the most important skills in this industry. The reason is simple. If your eval system is wrong, your model can look great in your internal test and still fail silently in the real world. Evals are how you define success. They capture tone and empathy, safety constraints, domain correctness, escalation rules, multi-run consistency, and much more. At Nurix, we think about evaluation across all the three layers. We test ASR across different accents, languages, and mic qualities. From the response generation layer, we run domain-specific test suites like insurance, education, or banking. Hallucination checks, where we intentionally remove knowledge and see if the agent makes things up. Multi-step workflows, for example, verify policy, update KYC, send a summary. Interruption test, where the user changes their mind mid-sentence. And finally, we evaluate end-to-end latency, from user finishing a sentence to the agent starting to respond. Naturalness of voice, emotional match for different call types, consistency of persona across sessions. All of these runs not only on static datasets, but also on real conversation replays. We take anonymized call logs, feed them back through the system, and score every turn. The goal is simple. If something breaks, we want to see it in our evals before your customers see it on a live call. NuPlay is the engine that makes all of this possible. It gives you the data and the control you need to decide whether these agents are actually good enough for production.